Today I'm going to talk a lot about multiple choice questions, so I thought it would only be fitting to begin this video by testing all of you with a multiple choice question. So let me ask you, which of these do I think best describes multiple choice evaluation with LLMs? Do I think it's A, forced and used too often, B, flawed with some fundamental issues, or C, fixable with lots of room for improvements? If you've read the title of this video, you could probably guess that I think the answer is D, all of the above. So, hi, my name's Nishant, and I'm excited to present our position paper at ACL 2025 on why multiple choice questions are terrible for evaluating natural language processing systems like large language models, and what we can do about it. To first give some background, a multiple choice question, or MCQ, has a question and set of choices, and we often use MCQs to see if models can select the correct answer from these choices, while avoiding the incorrect but plausible sounding distractor choices. The NLP community likes MCQs for a few reasons. First, they're easy to score. The model only has to pick from a handful of choices, and that choice is either right or wrong. It also roughly aligns with how we often test students in the United States, since many students are expected to take standardized multiple choice exams for college admissions. And finally, this task has historically been used in NLP, even considered a grand challenge of AI. For these reasons, MCQA is unavoidable. If you wanted to release the most popular dataset on Hugging Face, prove that your shiny new LLM is smart, or in my case, graduate with your PhD on time, it's really hard to avoid this task. But despite this popularity, our NLP community hasn't really considered if we are using MCQA correctly to evaluate LLMs. This position paper argues, no, we are not, for three main reasons. First, MCQA's format is inherently limited, restricting how well we can evaluate model capabilities. Next, even if you disagree and think evaluating LLMs with MCQA is still worthwhile, the community isn't always crafting the best MCQs possible. And finally, LLMs still fail on MCQs in spectacular ways, but we argue many of these failures link back to issues in MCQA's format and datasets. While I would love to rant about all of these problems, for the sake of time, I'll focus on just a subset of these issues, but check out the full paper if you would like to learn more. And along the way, I draw connections to how educators have already solved many of these problems, because these researchers have long been studying the best ways to construct MCQs. With that being said, I'll start by going over issues in MCQA's format. We all like MCQA because it is simple, but if that's all we cared about, why do humans hate taking these exams? If you count yourself among that group, it may be because MCQs don't predict how well you would do in the real world. Because of this, other countries opt for other testing formats to better assess students. So clearly, we have no problem ragging on MCQA when it comes to human testing, so we should be just as critical with LLMs. With this in mind, I'll go over two issues in MCQA's format, along with some better alternative formats drawn from education research. LLM evaluation should tell us which LLMs we should use. But if this is the case, evaluation should use tasks that mirror how people actually use LLMs. But with MCQA, this is certainly not the case. MCQA is used in several evaluations for LLMs like ChatGPT, where 71% of the tasks were in an MCQA format. Other benchmarks like the OpenLLM leaderboard also have lots of MCQA. This wouldn't be a problem if people actually used LLMs to answer multiple choice questions. And despite what you might have heard from professors complaining about kids these days cheating with AI, this is at best a niche use case. Studies analyzing real ChatGPT queries show that almost all of them involve free-form text, not MCQA. And when we looked at the finer grained breakdown of the types of queries people ask ChatGPT, we estimate only 7.25% are MCQA, which is starkly different from the 71% we saw for ChatGPT's evaluation. Basically, even if our LLMs do well in MCQA, it does not guarantee that they will actually be able to help us. One counter-argument is that MCQA was never meant to mirror real use cases, but evaluate core model abilities like knowledge. To examine this claim, we reviewed research on Bloom's taxonomy, a standard way of categorizing the level of thinking abilities required for answering different study items. Most MCQs test lower order skills, like recalling basic facts, while educators struggle to write MCQs for higher order skills like reasoning and creativity. This is a problem, because if we want to claim that our models possess this in-depth knowledge, we can't evaluate them with a format like MCQA, where it is almost impossible for them to demonstrate it. Now that you've endured my MCQA is bad rant, you might be wondering what I think would be better. Drawing from education research, we propose two modifications to MCQA that would improve its evaluative power without being impossible to implement. First is constructed response. Remove the choices and have models answer the question, similar to short-form QA. The second is explanation MCQA. You still measure if models select the correct answer, but you also evaluate their explanation or justification for the answer. These formats have many advantages, since they are generation tasks that better match how people use LLMs, and education research shows that these formats better assess the knowledge of students. An obvious drawback that many people bring up, including our reviewers, is that they require evaluation metrics that are harder to implement. I always found this point a bit silly, since as a community, we can always improve our evaluation metrics, but if we stick to a format like MCQA, it is much harder to improve how well the format inherently evaluates models, even if the metrics are perfect. Many recent papers, like OpenLLM Leaderboard and Big Gen Bench, show it is feasible to implement constructed response and explanation MCQA as better alternatives to traditional MCQA. I now want to spend the second half of this video talking about issues in MCQA datasets. You might wonder, why even talk about this? It's because for certain abilities like comprehension, or tasks like using LLMs to compare outputs, MCQA is the right format to use. Or in the worst case, maybe I still haven't convinced you that MCQA's format is bad at all. Even if that's true, I hope I can convince you that there are issues in MCQA datasets that we need to address. In fact, we find that these issues come up in almost all stages of dataset construction. Now, I'll focus on just 3 of these. The first issue is that many MCQs are impossible to answer, which could be due to them having multiple valid distractors, poor grammar, incorrect labels, or even missing information. This is bound to happen, since the researchers who construct these questions don't know how to write MCQs like experts. So instead, we should be following educators' guidelines for writing MCQs. These rubrics contain best practice for writing them, including general advice, as well as concrete suggestions for each part of the MCQ. We specifically think researchers should spend more time constructing distractors when authoring MCQs, since this is arguably the most important part of the question that distinguishes test takers. But we find researchers often use practices like random sampling, which are misaligned with the techniques used in education. Next, even if your MCQs are answerable, they may still be cheatable with shortcuts. To illustrate, when a model answers this MCQ, find all zeros in the indicated finite field of the given polynomial with coefficients in that field, x cubed plus 2x plus 2, we would hope it follows the intended solution. In this case, finding the zeros of the equation. But if you're anything like me, you'd have no idea how to solve this question, so you might fall back on a simple trick to come up with the correct answer, like picking the only choice with 2 numbers. If this happens, it means the MCQ contains shortcuts. And the paper, What Does My QA Model Know?, has found that models can answer MCQs with just the choices much higher than random. This is a problem because in both cases, we mark the model as equally correct, so we may overestimate its knowledge. A simple solution is to design datasets consistently. Specifically, my own work has found that if correct answers and distractors have obvious differences, models can pick up on this. A clear culprit of this is HelloSwag, a common-sense dataset where humans write choices and models generate distractors, yielding the highest known choices-only accuracy. Because of this, it's important to write MCQs consistently to avoid leaving behind these shortcuts. And finally, even if you do all of this to make your dataset perfect, hill climbing is inevitable, where models saturate the accuracy on your dataset. When this happens, you can either try to filter harder subsets of your data or write new, more challenging questions, and now I'll focus on the latter. Currently, to write harder questions, the dominant approach is to make questions that are insanely difficult to answer both for models and humans. A recent culprit of this is Humanity's Last Exam, where if you give ChatGPT any of these questions, you might celebrate at first, since the model got it wrong. But your celebration may be short-lived, since after looking at this response, you'd have no idea why your model got it wrong and how you could fix its errors. In response to this, we argue there needs to be more work on adversarial data collection, questions that are hard for models but easy for humans. Here I have an example adapted from my labmate Yu-Yun's paper AdScore related to SpongeBob SquarePants, where ChatGPT still answers it wrong, but now it's much easier to pinpoint why the model got it wrong. This could help OpenAI more easily fix the model in the future. We think the key challenge in this line of work is figuring out how to make writing these adversarial MCQs easier and more fun. We covered a lot in this video, so I want to conclude with what are some best practices if you're looking to build the best benchmark ever. First, we think you should clearly define the ability you want to measure. If that ability matches a downstream task, just use that task. If it's a more basic skill like knowledge, then you could consider formats like MCQA, but we would also urge you to consider alternatives from education research. Once you've decided on the format, you can start to construct your dataset, making sure to pick fresh sources, use rubrics to guide your MCQ writing, remove any shortcuts before releasing the dataset, and aim for hard but interpretable MCQs. This does require more work than what we currently do, but we argue if we don't put in this effort, we can't claim MCQA measures what we think it does. Thank you all for listening. I wanted to thank my amazing advisors at UMD and other friends and collaborators who have helped shape this work. And please, if you think I'm wrong in any way, feel free to email me or leave a comment. We need to have these conversations to make our evaluations more meaningful. We'll be presenting this work as an oral and poster at ACL 2025, so please visit either if you have some counter arguments and think you could change my mind. Thank you.